All right, so now we're going to do the second part of the notes for topic 9, circles. And this is a continuation of graphing circles, only the circles will not come to us in circle, radius, or standard form. They will come in a general form that we will have to rewrite to be able to identify the center and the radius. A pre-skill to that is something we did in regards to factoring perfect square trinomials. So let me remind you of what a perfect square trinomial is. A perfect square trinomial is a 3-termed polynomial that satisfies the following conditions. The coefficient of the first term, so that would be that number there, and the third term are perfect squares. So in x squared plus 6x plus 9, 1 is the coefficient of x squared. That's a perfect square. 9 is a perfect square. So that's the first part in identifying a perfect square trinomial. The second part is that the middle term must be the result of multiplying the square root of the first coefficient times the square root of the third term times 2. So if this is a 1 here, we're going to do the square root of 1 times the square root of 9 times 2, and that's going to give us 6. So this is, in fact, a perfect square trinomial. Perfect square trinomials always factor into the square of a binomial. That is the pattern for factoring perfect square trinomials. You will need to know that pattern in order to be able to work with circles in general form and converting them to standard center radius form. So how do we create that binomial? Well, you square root the first term of the trinomial. So if I square root 1x squared, I get x. Whatever the first sign is, you keep it. And then you square root the third term. The square root of 9 is 3. And that is the factoring of a perfect square trinomial. I know that you could use guess and check or split the middle and end up with x plus 3 times x plus 3. But perfect square trinomials will always factor into the same factor twice. And so we want to write that in proper notation as the square of that one binomial. Let's look at the second example. Y squared minus 10y plus 25. So that is indeed a perfect square trinomial. And that is going to factor into the square of, go to the first term and square root it. Square root of y squared is y. Go to the third term and square root it. The square root of 25 is 5. Go to the first sign in the trinomial. That's a minus, so that's a minus. Okay, third example. Again, let's test to see that it is a perfect square trinomial, even though they all are. So you're looking at your first term, and your first term is a 4x squared. 4 is a perfect square. 49 is a perfect square. And if we look at our middle term, we see that 28 is the result of the square root of 4 times the square root of 49 times 2. So that would be 2 times 7 times 2 is 14. So this is indeed a perfect square trinomial. Now, something else I need to point out, in a perfect square trinomial, the second operation, the second sign, is always a plus. So it's always plus c. So plus 9, plus 25, plus 49. How do we factor that? That's going to be the square of, so now you're going to square root 4x squared, and that's 2x. You're going to square root 49, that's 7, that minus becomes the sign. And so that's a review of factoring perfect square trinomials. Now, we didn't really need to know the pattern to factor earlier, but now you're going to see how it applies to working with circles. Complete the square to convert the circle equations into circle radius standard form. Then determine the center and radius. So in other words, we're going to convert from this general form to center radius or standard form. And we're going to do something called complete the square. What does that mean? It means that we're going to take two terms that are part of a perfect square trinomial and turn them into a perfect square trinomial. For example, we're going to take the equation right now in this general form, and we're going to group the terms that have the same variable. So x squared plus 4x plus, and then I'm going to leave a blank, plus y squared minus 8y plus, and then I'm going to leave a blank, and I'm going to move that 4 to the other side. Here comes the process called completing the square. This third term that is missing from the trinomial x squared plus 4x plus blank, y squared minus 8y plus blank, these are going to be perfect square trinomials. Perfect square trinomials. Now, if this is going to be a perfect square trinomial, then that means that third term has to be a perfect square, because we just talked about how to recognize that it is a perfect square trinomial. And we know that if we take the square root of the first term times the square root of the third term times 2, we're going to get the middle number 4. And so to reverse that, all we have to do is take half of that 4. So take 4 divided by 2 and then square it, and that's what goes in the third position, or the third term. So 4 over 2 is 2. 2 squared is 4. We have now created a perfect square trinomial. Let's move on to the y terms. We're going to take that middle number, divide it by 2, and then square it. Notice that I'm not carrying down the fact that it's a negative 8. It doesn't really matter, because we know that that third term is a positive, because in order to be a perfect square trinomial, that third term is always positive. And if I'm squaring, it doesn't matter whether the inside is positive or negative. When you square it, it's going to be a positive. So 8 over 2 is 4. 4 squared is 16. So I've created two perfect square trinomials. Now, while I was doing that, I added a 4 and a 16 to the left side of the equation. In algebra, whatever we do to one side of an equation, we do the same thing to the other side. So that means I have to come over to the other side, and I have to add a 4, and I have to add a 16. And so you can see that I've created balance. So there I am adding the 4 and the 16 that I added to the other side. On the right side, I'm going to get 16. Negative 4 plus 4 is 0, plus 16 is 16. On the left side, let me write that down a little bit. On the left side, I am going to take my perfect square trinomials and I am going to factor them as the square of a binomial. In doing so, we are going to be able to have our final equation of the circle look like center, radius, standard form. So x squared plus 4x plus 4 is going to factor into x plus 2 quantity squared. Let's go through that. How do we know what goes in the binomial? We take the square root of x squared. That gives us x. We take the square root of 4. That gives us 2. Whatever the first sign is, that's a plus, goes in the binomial. Plus, and now we're going to do the y. Y squared minus 8y plus 16. We're going to do the square root of y squared. That's y. We're going to do the square root of 16. That's 4. That first sign is a minus, so that's a minus. We now have the equation of the circle transformed from that general equation to center, radius, or standard form. In this form now, we can identify the center and the radius of the circle. So my center is, look at x plus 2 squared. So that's going to be a shift to the left 2. So that's negative 2, comma, positive 4 is my center. My radius is the square root of 16, or 4. So what we did for each piece of that circle equation is we completed the square. So x squared plus 4x plus 4. This 4, that's called completing the square. So we completed it to turn it into a perfect square trinomial. Okay. So we're going to rewrite to standard form and identify the center and the radius. So I'm going to pause, and I'm going to have you try to do exactly what I just did. And in the box, in Edpuzzle, I'm going to have you put the center and the radius. If you get confused, back up the video and listen and look at what I did previously. Okay, so I'm going to group x squared plus 10x plus blank plus y squared minus 2y plus blank equals negative 1. Here I go completing the square. I did 10 divided by 2, and I square it. So 10 over 2 is 5, squared is 25. As soon as I add that 25, I'm going to balance it by adding it to the other side. So that's kind of important, and I do it all at once so I don't forget. I'm going to come over here and complete the square on this one. So that's going to be 2 divided by 1 squared. 2 divided by 1 is 2, squared is 4. No, sorry, let's try that again. You're dividing by 2. So 2 divided by 2 is 1, squared is 1. Sorry, we're dividing by 2 and then squaring. And then we're going to add it to the other side. All right, on this side, we're going to get a 25. On the left side, we are going to factor the perfect square trinomial. X squared plus 10x plus 25 factors into x plus 5 squared. So you square root of x squared, you get x. Square root of 25, you get 5. Whatever the first sign is whatever the first sign is in the binomial. Y squared minus 2y plus 1 becomes y subtract 1 quantity squared. So my center, negative 5, comma 1, and my radius is 5. So I'm going to pause for a minute, and I want you to write in the box, did you get any of it correct? And if so, what did you get? Did you get the center correct, the radius correct, or both? Okay, moving on. Let's talk about some other types of questions that relate to working with circles in the coordinate plane. One of those types of questions deals with the word tangent. And tangent is a word that you learned in geometry. And a tangent is a line that touches a circle at exactly one point. And we're going to use this geometry term while we're graphing and writing equations of circles. So the 0.34 lies on a circle. All right, so I'm going to come over here and I'm going to plot 1, 2, 3, 1, 2, 3, 4. Center at the origin. What is the radius of this circle? So if I draw a segment, that is the radius of that circle. So this is the center, right? And this is any point XY on the circle. So to determine that radius, we need to find the length of the segment. And we know that when we're finding length, we're using distance formula. So that's going to be the distance is equal to 3 minus 0 squared, because we know this is the 0.00, plus 4 minus 0 squared. I'm going to go ahead and pause and let you determine what that length is. Okay, so D equals the square root of 9 plus 16. An order of operations would tell us that you have to add first. So that's the square root of 25, which is 5. So the radius of the circle is 5. All right, so if the radius of the circle is 5, then that would mean that I can plot a point there, and here, and here, and here, and I should be able to draw a nice circle. So I'm going to give it a shot. There we go. And Notability is super nice because you can do a semi-decent job and then hold your stylus down and it will make a nice perfect circle. All right. What is the equation of this circle, right? So we know that the center is 0, 0. And so when the center is 0, 0, we don't use the HK. We use x squared plus y squared equals r squared. And so that's going to be x squared plus y squared equals 25. All right. What is the slope of the line tangent to the circle at 3, 4? All right, so let's review tangent. A line that touches a circle at exactly 1 point. So I want you to go up to your circle, right? And I want you to draw in the line tangent to the circle at 3, 4. All right, there we go. So you can see now, and I'm going to highlight it purple, that at 3, 4, that line is touching the circle. It's also touching the radius. In geometry, you might have learned the following property. A line tangent to a circle at the radius is perpendicular to the radius. Okay, now I just used a symbol there, an upside down T. In geometry, that is the symbol for perpendicular. What it means is forming a right angle. Perpendicular means a right angle. That means I can come back over here and put a little box, hopefully you remember this from geometry, and put a right angle there. All right, we still have not addressed the fact that this asked for a slope. What is the slope of that line, right? Now, I might be able to count off the slope on the grid, right? But I don't know that I would be assured I was 100% accurate. And so we have to revisit perpendicular lines, okay? Perpendicular lines, bad writing. Let's try that again. perpendicular lines have slopes that are opposite reciprocals. Okay, finally now we can determine the slope. Okay, so the slope of the radius is up 1, 2, 3, 4 over 1, 2, 3. So 4 over 3. So the slope of the tangent is -3 over 4. And I suppose I could probably guess that. Let me pick a different color here. Let me pick like orange. If I went up 1, 2, 3 over 1, 2, 3, 4, looks to me like that represents the slope of that tangent line. So let's recap. A tangent line is a line intersecting a circle at exactly one point. The tangent line is always perpendicular to the radius, forming a right angle. When two lines are perpendicular in a coordinate plane, their slopes have the property that they are opposite signs and reciprocals. All right, part D. What is the equation of this line in slope-intercept form? Okay, well, for that line, we know that the tangent line has a slope equal to -3 over 4, and it passes through the point 3, 4. So we're going to go back to an equation called point slope. Y minus y1 equals mx minus x1. And we're going to dump in that information. So we're going to dump in our slope and our point into our point slope. So that's going to be y minus 4 equals -3 over 4 x minus 3. Now, it said to put it into slope-intercept form, and so, as you remember from algebra, you're going to distribute and simplify. So that's going to be y minus 4 equals -3 over 4x plus 9 over 4. And then we're going to add 4 to the other side, so that's going to be y equals -3 over 4x. Add the 4, and you're going to get 25 over 4. So I did that in my head. I did 9 over 4 plus 4, and I got 25 over 4. And if you can't do it in your head, grab that calculator. And that is the equation of that tangent line. So you can see how working with circles, we're connecting some of our algebra and geometry that we've learned before. Okay, last part of this. What is the exact area and circumference of this circle? All right, so the area is pi times radius squared, and the circumference is 2 pi r. So this is just typing in information into the equation. So if the radius is 5, that's going to be pi times 5 squared, which is 25 pi. Notice it said the word exact. So we are not using 3.14. We are not using our calculator. This is called exact. So we just leave pi in our answer. For circumference, 2 times pi times 5 is going to give me 10 pi. This would be units squared, and that would be units. Alrighty. Lots of information on that problem. Last problem. Find an equation of the circle whose center is at the point -4, 2. So I'm going to plot -1, -2, -3, -4, -1, -2. right? Well, at least I know the center point. So I know -4, -2 represents h comma k. Now we see this word tangent again. So find the equation of the circle whose center is that point tangent to the y-axis. All right, so here's the y-axis right here. Okay, so if the circle is tangent to it, then that means that the circle can only touch it at one point. Remember, go back up to the top. What is tangent? A line that touches a circle at exactly one point. So this vertical line, this y-axis, can only touch that circle with that center at that one point, which would lead me to believe that the radius of that circle, 1, 2, 3, 4, is 4. Which means from that center, I can count up 1, 2, 3, 4. I can count 1, 2, 3, 4, and I can count down 1, 2, 3, 4. And using my stylus, I should be able to get a fairly decent circle. There we go. We have not come up with the equation of the circle, but it's pretty easy now to see that the radius is 4. And so my circle equation in circle radius form is going to be x minus h squared plus y minus k squared equals r squared. And that r is 4. Simplifying, x plus 4 squared, y plus 2 squared equals 16. I'm going to pause it one more time, and I'm going to ask you to put in the box any of the concepts on these notes that you would like me to go over.